SDA, serial clock and serial data connected to the CPU. If you get 5 volt here, then CPU. First, let me tell you little bit about VBUS line, how this VBUS line work and how this VBUS line enter the charging IC. When you connect a charger on charging port, you will get 5 volt on this charging connector. Also, with this connector attached TP test point, you will get also a 5 volt. After this line called VBUS, this line first goes to the OVP IC, right? Over voltage protection IC. After this IC, this line goes to the R charging IC, DC to DC. Now, if OVP IC open or damage, how to bypass OVP IC? How to check VBUS line before entering the charging IC? I will given you all detail in previous videos. So if you don't know about this line, please check out the previous video with animation and block diagram. I will give you all information how to read a data sheet of BQ series. I'm telling you in this video all the lines of this IC. Now start the topic. VBUS line. After the OVP IC, this line connect to this IC pin number 1 and pin number 24. In this line you will get 5 volt. After the OVP IC, this line first connect the pin number 1 and 24 in BQ IC 25601. Pin number 1 and 24 enter VBUS line, voltage bus. If you check here in a capacitor, you will get 5. After this, pin number 23, a capacitor installed. This line called PMID, VMID, MID in schematics. If you check these names on this capacitor, you will get 5 volt. If you get here 5 volt, it means the VBUS line from charging connector to this IC, this all line are okay 100%. If you get 5 volt on PMI line, that means from charging connector to this IC, this line all are connected to this point. If you get 5 volt, right? If you don't get here 5 volt, that means this line somewhere break. Or if you get this capacitor, last capacitor 5 volt, but you did not get 5 volt on PMID gap, that means this line break somewhere between this gap to, it means this line not connected properly. This line not connected between IC, under the IC. The pad may be dry or loose. If you get 5 volt here, that means this line, all VBUS line are proper, okay. If this cap was missing, PMID cap was missing, because sometime this cap connected on a parallel line, right? Some people remove this cap, but if this cap is missing, your phone on fake charging. Your phone does not charge, only show the charging logo, not consumption any ampere, right? If this cap is short, that means your primary line is short. Clear? Now after this pin number 19 and 20 is switching pins. Here these two pins are switching pins. There is a MOSFET, right? Switch with the ground in microseconds. After the VPH power generate, this VPH power distribute all of your phone, like network section, audio section, LCD section, light section, each and every section, because this is the main voltage VPH. If you don't know about VPH, I will give you all information about how VPH works, how VPH distribute, if VPH had short or any problem, how to solve in previous video. So please check out the video. Now this MOSFET switching with the ground and VPH generate. Every switching line had 3 components: coil, capacitor and a diode. Diode is installed inbuilt in this IC, right? For example, in light section, you must have seen that a diode, a boost coil, also a heavy value capacitor, right? After the switching creates. Same logic here. After the switching, the VPH generate. In this line, one more capacitor connected in series. One side connected with VPH line here, other side connected with this IC. This capacitor called BTST cap, bootstrap cap. If you see in schematics, you can see BTST cap or boot cap. So you will get one side 7 to 8 volt and other side 3.7 to 4 volt. This cap on series, right? One side you will get 7 to 8 volt, other side you will get 3.7 to 4 volt. If you did not get here voltage, or if this capacitor was missing, your IC could not switching, your IC does not work. or create VPH. So if you get here 4 volt or 8 volt on both sides, that means your IC is switching properly. Clear? Now this is VPH coil. What is VPH coil? I'm telling you in previous video. So please check out the previous video. Now after this, a line goes back to this IC. Same. This line call in MediaTek V system on Qualcomm VPH line. Right? V system in MediaTek. After this, a MOSFET in this IC took this voltage and generate another line called charging out line. This line goes to the charging connector to charge the battery. Right? Charging out. In this line, you will see a 0.01 ohm or 0.01 to 10 ohm resistance called CNC resistance or shunt resistor. Like this resistance work measure the current in battery or how much need battery current at this moment when you connect the charger. Right? This resistance connected with the fuel gauge section. Most of the fuel gauge section in built-in power IC or PMIC. But in this model, this IC installed separately. So how this fuel gauge IC work, each and every ball I will discuss or I will giving you detail in this video. But before that, I will give you all information, all the lines I will tell you of this IC. Clear? Let me show you these lines in schematics. Right now, I'm already open the Borneo. First, we go to the PCD section. Why? I will tell you. Now you can see here in this section part compatible database. In this section, if I type IC number BQ25601 and enter, you can see here this IC used in many companies with different models like Xiaomi, Oppo, Motorola, Vivo, right? Infinix, Huawei, also Samsung. Most of the company use this IC Motorola with latest and old models. I showed you because so that you don't feel like I'm teaching you in old IC to you. BQ series update version of this IC coming to many new phones. Not BQ25601, other BQ series update version used by all companies latest model. So if you learn or if you understood this IC data sheet, you will learn update version easily, right? So get back to the schematics. Now you can see here I'm already open this IC. You can see here BQ25601. Now according to the block diagram, pin number 1 and 24 enter VBUS line. You can see here pin number 1 and 24 enter VBUS line. VBUS. So if you check here in this capacitor, you will get 5 volt. I'm already told you. After the pin number 23, a PMID cap. What is PMID cap? I'm already told you. You will get here also 5 volt. After that, pin number 19 and 20 switching with ground. From this pin, a VPH generate, right? Then VPH goes to the all other section. Now in this line, you will see a coil, right? Also a cap connected in this line. Also other side connected with the pin number 21 called BTST cap, bootstrap cap. In this cap, you will get one side 4 volt and other side 8 volt. I'm already told you in block diagram. I will show you first. In block diagram, you can easy to learn. So I'm creating block diagram for according to the IC. Now in this line, you can see here VBUS in after the PMID cap, a bootstrap cap, BTST cap connected with the VPH line. These 19 and 20 pin create VPH. After this, a line goes back to the same IC called V system, and after that, through a MOSFET, a charging out line generate. Right? This line goes back to the battery connector. I will show you in schematics. Now you can see here there is a BTST cap. Now a line goes back to this line. You can see here this line goes back to the same IC, pin number 15 and 16. After that, a MOSFET here, create charging outline. This line goes to the battery connector for charge the battery. I will show you in this line. When you click this line, now in this line you can see here there is a resistance called CNC resistance 0.010, a micro value resistance. If you check on a beep mode, this resistance sound beep. This resistance purpose, I'm already told you what is this resistance purpose. Now this resistance, one side connected with the V battery, voltage battery means battery connector, other side connected with the charging outline. So both sides connected with two lines connected with this IC. What is this IC? This IC called fuel gauge IC. I'm telling you each and every pin in few minutes. After completing the BQ IC, all pins, I will tell you all these pins, how these IC work. Now get back to the block diagram. Now you can see here there is a resistance and two lines SRN and SRP. Connect with the fuel gauge IC. This line connect with the charging out. Now in block diagram you can easy to learn except the schematics. Right? Now after this, pin number 22 I will draw first in block diagram. Pin number 22, REGN line, right? REGN line, right? Means regulator voltage line. On this line you will get 5 volt. How? A MOSFET installed in this IC connected to VBUS line or PMID line. Other side connected with this REGN line, right? So you get 5 volt on VBUS line, 5 volt on PMID line, same 5 volt on REGN line. Now I will show you in schematics. So schematic. Now you can see here pin number 22, REGN line, right? Where this pin going, just click. Now this pin goes back to the same IC, right? You can see here REGN pin number 22. After this REGN, regulator voltage line, right? Now same voltage you can see here 5 volt, but in this line pin number 11 called TS. TS means thermal sensing. For sense the, if this IC heat, sense CPU. So this point is thermal sensing point. In this point you can see here two resistors 10K each creating divider circuit. Now what is divider circuit? I am explaining already in previous videos. Go and check out. This line for thermal sensing with a thermal divider circuit. Now according to the divider circuit formula, when two resistance in same value R1 and R2 had become a same value, input voltage get half. In this line you will get here on 11 number pin 2.5 volt. Clear? After connect the battery or charger, if you get 5 volt here, then CPU stop the working of this IC through I2C lines. Clear? CPU sense all these information, each and every point through SDA and SCL line, serial data and serial clock line. These two lines connected with the CPU. CPU getting all information about this IC. Now if pin number 11 voltage disturb, or you can say a divider circuit, any resistance miss or open, so you get 5 volt here. After that CPU sense something is wrong, IC heats to according CPU IC heat, so CPU stop this working IC to work. Clear? So you can must check here RNG line or divider circuit, right? On 11 number pin you will get 2.5 volt. If any resistance open or damage, you just replace the same value resistance. Clear? If you not had 10K resistance, but if you have a 200K resistance, then replace with 100K resistance, both of. because according to the divider circuit formula, when both resistance R1 and R2 are same value, resistance will be half. Clear? Understood? Now draw this in block diagram. Clear? Now this REGN line get 5 volt. After this line, connect with the TS line. Thermal sensing, both resistors are 10K. After that, you will get here 2.5 volt. Clear? After this line connected with the pin number 2 called PSEL line, power source selection line. Go to the schematics. After I am explain about this line. Now you can see here pin number 2. When you click here REGN line, now become a REGN line. Also will get here PSL line. Now you can see there is a 2 resistance creating divider circuit, but this resistance is clearly not fitted and phi. So you get here only 10K resistance. One resistance value 10K. Right? This line is power source selection line. Clear? This line for fast charging. Right? In this line you will get 5 volt. If everything okay according to this IC or CPU, this IC enable fast charging. Clear? If this line break, suppose this 10K resistance open or miss or break, then your phone charging on normal mode, like consuming 0.6 ampere, a half ampere. Clear? But enable to fast charging from 1.2 ampere to 1.6 or 2 ampere charge. This line will be okay. If this line okay, power source selection, your IC will get enable fast charging, because this IC PQ25601 is 2 ampere IC. Clear? Now next you can see here pin number 5 and 6. I am already told you 5 and 6 SDA and SCL, serial data and serial clock. This line connected to the CPU, right? GPIO means CPU. Clear? These lines are I2C lines, right? Connected to the CPU. Now draw into the block diagram, right? SCL and SDA, serial clock and serial data connected to the CPU. These are I2C lines, right? Now through this line, CPU control this IC. Also take all information of this IC, like TS line and all these information, if IC working well or not. Now if this line had a problem, but this line connected direct to the CPU, no component involved in this line, rare chances this line damage. Next, pin number 7, INT line. You can see here INT line means interrupt. This line connected with the CPU, right? Also this line get 1.8 voltage from power IC, connect with the pull-up resistance, this resistance, right? In this line you get 1.8 voltage from power IC. Also this line connected with the other side from other side to the CPU, right? Now I will explain you this line in schematics. Now get back to the schematic. Now pin number 7, interrupt. You can see here this line had 2 points, VREG voltage regulator L5 1.8. These are LDO 1.8 line from power IC with a 10K resistance. Clear? Also another line goes to the CPU SMB INT interrupt, right? You can see here GPU, right? Now this line connect with the 1.8 voltage from 10K resistance. Now get back to the block diagram, right? If this line damage, your charging symbol does not show. When you connect a charger, this line had 1.8 voltage pull up to pull down. from internally CPU. When you connect the charger, CPU, this point connect with the ground. So 1.8 voltage goes drop. After that, CPU create a charging symbol to your display, your LCD. Now next, pin number 3 called PG, power good. When your phone is off, when you connect the charger on off condition, when your phone is switch off, when you connect the charger, on this condition, this IC gives signal to the power IC because this line connected to the power IC. So this line signal gives to the power IC. A charger connect. After this charger power IC generate our secondary line like buck lines and LDO lines, because when your phone is switch off, power IC does not activate. When you connect the charger through this line, power IC boot and generate secondary lines, buck lines and LDO lines. After this, your power IC through CPU generate charging symbol on your display. When power IC activate, after this power IC show your charging symbol on your display when your phone is switch off. If this line is damaged, power good line, your phone does not charge in off condition, on switch off condition. Clear? In some phones, this line also called system OK. Clear? If this line damage, your phone does not charge on off condition. Let me show you in diagram. Right here, pin number 3, PG, clear, CBL, power N, clear. Just click this line and this line goes to the your PM8937. This line connected to the power IC, I'm already tell you. So if this line is damaged, there is, when your phone is off, there is no charging. You can see there is a TP also, test point. You can check here also. Now go to the block diagram again. Now next line, QON, pin number 12, QON. In this line, a MOSFET, this line connected to the on off switch to reset the phone. This line connected to the on off switch. In built battery phone, if your phone is stuck, or you can say if your phone suddenly hang or stuck on, you can reboot your phone after pressing the volume, also pressing the power button. This can happen through this line, QON. I will show you in diagram. Now you can see pin number 12. Pin number 12, QON, keypad power. When you click this line connected to the, with the diode connected to the power on off button. One side connected with the power IC, other side connected with the on off switch. Clear? Now back to the block diagram. Anything miss? VBUS line clear. Pin number 124, switching line clear. I will all explain to you. BTST clear, PMID clear. 10 number pin is NC, REGN clear, PG clear, P ground, power ground, point connected to the ground, IC ground, NC, SDA clear, SCL clear, interrupt clear. This point is also NC 8 number pin. System is clear, charging out is clear, QON is clear, right? TS is clear and PSAL. All these lines I'm all explained to you. Let's go to the block diagram. I'm explaining all these lines, explaining to you fuel gauge IC. I hope you understood each and every line.